Hey, welcome back. In this episode, we're going to learn about architectural best practices for reliability. Building a reliable application in the cloud is different from traditional application deployment. While historically, you may have purchased levels of redundant higher end hardware to minimize the chance of an entire application platform failing. In the cloud, instead of trying to prevent failures altogether, the goal is to minimize the effect of the single failing component. Reliable applications are resilient and highly available. So, how can you build for reliability? There are 6 steps for building a reliable Azure application. The first step is to define your requirements. So, develop availability and recovery requirements based on decomposed workloads and business needs. Second step is to use architectural best practices. Follow proven practices, identify possible failure points in the architecture, and determine how the application will respond to failure. Third step is to test with simulations and forced failovers. You can simulate faults, trigger forced failovers, and test deletion and test detection and recovery from these failures. Fourth stage is to deploy the application consistently. So release to production using reliable and repeatable processes. Fifth step is to monitor application health. You need to detect failures, monitor indicators of potential failures, and gauge the health of your application. And the sixth step is to respond to failures and disasters. So identify when a failure occurs and determine how to address it based on established strategies. So let's go deeper into how can you define requirements. The first stage is to identify workloads and usage. A workload is a distinct capability or task that is logically separated from other tasks in terms of business logic and data storage requirements. So each workload has its own different requirements for availability, scalability, data consistency, and disaster recovery. Then you have to plan for usage patterns. Usage patterns also play a role in requirements. Identify differences in requirements during critical and non critical periods. Then we have to establish availability metrics, which include mean time to recovery, which is MTTR, and mean time between failures, which is MTBF. MTTR is the average time it takes to restore a component after a failure. MTBF is how long a component can reasonably expect to last between outages. So you need to use these measures to determine where to add redundancy and to determine service level agreements for customers. Another step is to establish recovery metrics, recovery time objective and recovery point objective, which is RPO and RTO. So RTO is the maximum acceptable time an application can be unavailable after an incident. And RPO is the maximum duration of data loss that is acceptable during a disaster. Another thing to identify during the requirement stage is to determine workload availability targets. So to ensure that application architecture meets your business requirements, define target SLAs for each workload. Account for the cost and complexity of meeting availability requirements in addition to application dependencies. And understand the service level agreements. In Azure, the SLA describes the Microsoft commitments for uptime and connectivity. If the SLA for a particular service is 99.9%, you should expect the service to be available 99.9% of the time. Now let's understand the use of architectural best practices. During the architectural phase, focus on implementing practices that meet your business requirement, identify failure points, and minimize the scope of failures. The steps what you can perform here is perform a failure mode analysis, which is known as FMA. FMA builds resiliency into an application early in the design stage. It helps you identify the types of failures your application might experience, the potential effect of each, and possible recovery strategies. The next stage is to create a redundancy plan. The level of redundancy required for each workload depends on your business need and factors into the overall cost of your application. Design for scalability. A cloud application must be able to scale to accommodate changes in usage. Begin with discrete components and design the application to respond automatically to load changes wherever possible. And keep scaling limits in mind during design so you can expand easily in the future. Plan for subscription and service requirements. You might need additional subscriptions to provision enough resources to meet your business requirements for storage, connections, throughput, and more. Use load balancing to distribute requests. Load balancing distribute your application requests to healthy service instances by removing unhealthy instances from rotation. Build availability requirements into your design. Availability is the proportion of time your system is functional and working. Take steps to ensure that application availability conforms to your service level agreement. For example, avoid single points of failure, decompose workloads by service level objective, and throttle high volume users. Next is to manage your data. How you store, backup, and replicate data is critical, which include choose replication method for your application data, document and test your failover and failback processes, protecting your data, and plan for data recovery. We need to be very mindful of Azure service dependencies. Azure services are built for resiliency, including high availability and disaster recovery. There are no services that are dependent on a single logical data center. Non-regional services listed on Azure Global Infrastructure products are services for which there is no dependency on a specific Azure region. Non-regional services are deployed to two or more regions, and if there is a regional failure, the instance of the service in another region continues servicing customer. All Azure services that store customer data allow the customer to specify the specific region in which their data will be stored. The exception is Azure Active Directory, which has geo-placement such as Europe or North America. If you need to understand dependency between Azure services to help better architect your application and services, you can request the Azure Service Dependency Documentation by contacting your Microsoft sales or customer representatives. This document lists the dependencies for Azure services, including dependencies on any common major internal services such as control plane services. Testing for reliability requires measuring how the end-to-end workload performs under failure conditions that only occur intermittently. So, test for common failure scenarios by triggering actual failures or by simulating them. So, use fault injection test to test common scenarios, including combinations of failures and recovery time. Identify failures that occur only using load. So test for peak load using production data or synthetic data that is as close to production data as possible to see how the application behaves under real-world conditions. Run disaster recovery drills. Have a disaster recovery plan in place and test it periodically to make sure it works. Perform failover and failback testing. Ensure that your application's dependent services failover and failback in the correct order. Run simulation tests. Testing real-time scenarios can highlight issues that need to be addressed. Scenarios should be controllable and non-disruptive to the business. Test health probes. So you need to configure health probe for load balancers and traffic managers to check critical system components and test them to make sure that they respond appropriately. Test monitoring systems as well. So be sure that monitoring systems are reliably reporting critical information and accurate data to help identify potential failures, and include third party services in test scenarios. So test possible points of failures due to third party service disruption in addition to recovery. Let us understand how can you deploy applications consistently. Deployment include provisioning Azure resources, deploying application code, and applying configuration settings. An update may involve all three tasks or a subset of them. After an application is deployed to production, updates are a possible source of errors. Minimize errors with predictable and repeatable deployment processes. So, first, you need to automate your application deployment process. So, automate as many processes as possible. The next is to design your release process to maximize availability. So, if your release processes require services to go offline during deployment, your application is unavailable until they come back online. So, take advantage of platform staging and production features. Use blue, green, or canary releases to deploy updates. So, if a failure occurs, you can quickly roll back the updates. The next step is to have a rollback plan for deployment. So design a rollback process to return to the last known good version and to minimize downtime if a deployment fails. The next stage is to log and audit deployments. If you use staged deployment techniques, more than one version of your application is running in production, implement a robust logging strategy to capture as much version-specific information as possible. And finally, document the application release processes. So clearly define and document your release processes and ensure that it's available to the entire operations team. Implementing best practices for monitoring and alerts in your application so you can detect failures and alert an operator to fix them. The steps involved are: first, you need to implement health props and check functions, and check low running workflows, which is catching issues early so you can minimize the need to roll back the entire workflow or to execute multiple compensating transactions. And maintain application logs, which include log applications in production, use semantic and anonymous login, and separate application logs for audit logs. The next step is to measure remote call statistics and share the data with the application team, and track transient exceptions and retries over an appropriate time frame. Then set up an early warning system. This identifies the key performance indicators of an application health, such as transient exceptions and remote call latency. Then operate within Azure subscription limits. Azure subscriptions have limits on certain resource types, such as the number of resource groups, cores, and storage accounts. So watch your resource types. Then monitor third-party services. So log your invocations and correlate them with your application's health and diagnostic logging using a unique identifier. And train multiple operators to monitor the application and to perform manual recovery steps. So make sure there is always at least one trained operator active. Let us now look into the steps involved in responding to failures and disasters. First, plan for Azure support interactions. So before the need arises, establish a process for contacting Azure support. Then document and test your disaster recovery plan. So write a disaster recovery plan that reflects the business impact of application failures. Automate the recovery process as much as possible and document any manual steps. And regularly test your disaster recovery process to validate and improve the plan. The next step is to failover manually when required. So some systems can't failover automatically and require a manual failover. If an application failover to a secondary region, perform an operational readiness test and verify that the primary region is healthy and ready to receive traffic again before failing back. Then prepare for application failure. So prepare for range of failures including faults that are handled automatically and those that result in reduced functionality and those that cause application to become unavailable. And recover from data corruption. If a failure happens in data source, check for data inconsistencies when the store becomes unavailable again, and recover from a network outage. So you might be able to use cached data to run locally with reduced application functionality. If not, consider application downtime or failover to another region, and recover from a dependent service failure. So determine which functionality is still available and how the application should respond. And finally, recover from region wide service disruption as well. The region wide service disruptions are uncommon, but you should have a strategy to address them, especially for critical applications. You might be able to redeploy the application to another region or redistribute traffic. That was a long episode, and it was so much information packed into a single episode. So make sure you go back and pause each state and listen and take notes in between to understand it properly. In the next lesson, we're going to learn about how to recommend an Azure site recovery solution. I will see you on the next one. Until then, take care.